Okay, here we have section 6.6, which deals with trapezoids. So vocab, trapezoid, isosceles trapezoid, and median. Okay, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. Those are called bases. There are two pairs of base angles formed by one base and the leg. So you have a set of, so if you think about the shape. So base angle, and then those are also base angles. So two pairs of them. The non-parallel sides are called the legs. The parallel sides are called the bases. If the legs are congruent, that's now an isosceles trapezoid. So you can have a trapezoid, so like this shape here is a trapezoid if the top and bottom are parallel, but it is not an isosceles trapezoid because these two sides are not congruent. All right, so our theorems here, looks like 6.18. Each pair of base angles in an isosceles trapezoid are congruent. So an isosceles trapezoid, not any trapezoid. And the diagonals in an isosceles trapezoid are congruent. All right, so example 1 here, quadrilateral JKLM has vertices of that, and that. Verify that it is a trapezoid. So those numbers are real big. Let's see here. So what you'd have to do is you would plot your points. Probably should not have picked such big numbers. Yeah, we'll come over here. Actually, let's use some real graph paper. Okay, so J is at -18, -1. K is at -6, 8. L is at 18, 1. And M is at -18, -26. So let's just make a lot of graph paper here. So I'm actually going to count by twos to make this easier. So -6, 1, 2, 3, 8, 1, 2, 3, 4. Oops, that's K. I didn't start at the beginning. J is -18, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -1 would be, since I'm going counting by twos, so there's J. There's K. L is at +18, +1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's there. So that is L. And M is at -18. So that's back over here. -26, that's down 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's way down there. So that is M. So there, you can't really even see it all in one picture. So there's M, there's J. So J to K. K to L, that's a real bad line. M to L, J to M. So it looks like, you can see a little bit better that way. These are going to be my bases, so I just need to make sure that they are parallel. So this one is, remember, parallel slope. So 1, 2, 3, 4.5 up, and 1, 2, 3, 4, 5, 6 over. So the slope is 4.5 over 6. Down here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.5 up. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. From M to L. $17. Here, sorry, put back on the board. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 13.5 over 17 and 4.5 over 6. So let's make those real numbers. 4.5 divided by 6 that is 3/4. 13.5 divided by 17. I feel like I've plotted something wrong then. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. M is at -18. J is at -18. Because the slope did not come out to be 3/4, which I feel like it should be. This should probably be 18. 13.5 divided by 18. Yep, that should have been 18. They're 18 apart. Miscounted. So that's 3/4. So these two things are equal. So slopes are the same, so it is a trapezoid. To determine whether it's an isosceles trapezoid, I need to find the length from K to L and from J to M, and use that if those are the same, it's isosceles. So from K to L is the square root, so K and L, of x2 minus x1 squared plus y2 minus y1 squared. And for Jm, it's going to be x2 minus x1 squared plus y2 minus y1 squared. So 18 plus 6 squared plus 7 squared equals, so this is the square root of 625, and that one is also the square root of 625, which means the lengths are the same. So going way back to our example, we did that, and yes, legs are congruent. All right, so that one was fun. So here, segment that joins the midpoints is called the median. It is parallel and equidistant from each base. So here's the lovely theorem. So AB and DC are your bases. EF is the median. So the length of EF is 1/2 the sum of the bases. So example 2 here, which I think is the last example. Yep. In the diagram, QRST represents an outdoor shape in an isosceles triangle, which means that QT and RS are the same length. The median XY represents the sidewalk. Find TS if QR is 23 and XY is 15. So to do that, we need to use the median formula. So the length of the median is equal to 1/2 the sum of the bases. So one base is 23. I don't know the other base, so it's going to look like that. Now, instead of distributing the 1/2, I can get rid of by multiplying both sides by 2. So this becomes 30, or dividing both sides by 1/2, equals 23 plus x. So x is 7. So that's what TS is. So TS equals 7, which makes sense. TS is shorter than QR. All right, down here, find 1, 2, 3, and 4 if angle 4 is 4a minus 10, and angle 3 is 3a plus 25. So these are base angles, so they are congruent in an isosceles triangle. Oh, sorry, angle 1 is 4a minus 10. So these two angles add up to 180 because these are parallel. That's the transverse. They are same side interior. So 4a minus 10 plus 3a plus 32.5 is equal to 180. So that's 7a plus 22.5 equals 180. So 7a is equal to whatever 180 minus 22.5 is. Which is 157.5 divided by 7. A is 22.5, and then we just got to plug everything back in. So for measure angle 1, that's going to be 4 times 22.5 minus 10. So that's 80. And measure angle 2 is the same thing. It's the other base angle. Measure angle 3 and measure angle 4 will be equal to each other. So 3 times 22.5 plus 32.5 is 100. Now I could have actually gotten that a faster way because 1 plus 3 or 2 plus 4 have to be 180. So if those guys are 80, those guys are 100s. And that's the end of this section.